Hello viewers, welcome to the channel Amazing Civil Engineering Studies. Here we will learn about different concepts related to civil engineering. In today's video we are going to discuss about what is slump cone test. What is slump cone test? A slump cone test or concrete slump test is to determine the workability or consistency of the concrete mixture prepared in the laboratory or at the construction site during the course of work. A concrete slump test is performed from batch to check the uniform quality of the concrete during construction. The slump test is the simplest test of workability for concrete, involves low cost, and provides immediate results. Due to this fact, it has been widely used for workability tests. Principle of slump test. The result of the slump test is a measure of the behavior of a compacted inverted concrete cone under the action of gravity. It measures the consistency or moisture of the concrete, which gives an idea of the workability of the concrete mixture. The slump value of concrete is just a principle of gravity flow of surface of the concrete cone that indicates the amount of water added to it, which means how much this concrete mix is in workable condition. Slump test apparatus. Slump cone. Scale for measurement. Tempering rod, steel. Smooth surface pan. Trowel. Slump cone dimensions. Height 30 cm. Top diameter 10 cm. Bottom diameter 20 cm. Diameter of the tamping rod 16 mm. The concrete slump test procedure. All the apparatus should be free from moisture or any other affluent, and also it should be in dry condition. Step 1. First, place the slump cone mold over the smooth surface pan, then fill the fresh concrete in layers up to the slump cone mold top. Step 2. Each layer of filled concrete should be tamping up to 25 times by the tamping rod. Step 3. Fill concrete up to the top of the cone. Step 4. Level and remove the excess concrete from the top. Step 5. Slowly remove the cone mold in the vertical direction, and now the concrete will fall down on the pan. Step 6. Now measure the difference between the height of the slump cone mold to the concrete subsidence. The slump value will be measured in millimeter. The concrete slump test procedure. The mold for the concrete slump test is a 300 mm high cone-shaped trunk. The base is 200 mm, 8 in diameter, and has a smaller opening at the top of 100 mm, 4 in. The base is placed on a smooth surface, and the container is filled with concrete in 3 layers, whose workability must be tested. Each layer is tempered 25 times with a standard 16 mm, 5/8 in, diameter steel rod, rounded at the end. When the mold is completely filled with concrete, the upper surface is reached, flush with the upper opening of the mold, through the sieving and rolling motion of the quenching rod. The mold must be held firmly against its base during the entire operation so that it cannot move due to concrete leakage, and this can be done through handles or footrests welded to the mold. Immediately after completing the filling and leveling the concrete, the cone is slowly and carefully lifted vertically. An unsupported concrete will now slump. The decrease in the height of the center of the slumped concrete is called a slump. The slump is measured by placing the cone just beside the slumped concrete, and the quenching rod is placed over the cone so that it also exceeds the area of the slumped. The decrease in the height of the concrete in relation to that of the mold is observed in, usually measured up to the nearest 5 mm, 1/4 inch. Ideal value of slump for works, chart. Precautions in the slump test. Concrete slump test. To reduce the influence of slumping variation in surface friction, the interior of the mold and its base must be moistened at the beginning of each test and before lifting the mold. The area immediately around the base the cone must be cleaned of concrete that may have slumped accidentally. Types of concrete slump. Slumped concrete takes various forms and, according to the profile of slump concrete, the slump is termed as true slump, shear slump, collapse slump, true slump. When the slump cone mold removal, the concrete eventually slides down but it possesses the mold shape. In a real slump, the concrete simply disappears, maintaining more or less the shape. This is the only slump that is used in several tests. Mixtures of rigid consistency show a zero slump, so that, in the very dry range, no variation can be detected between mixtures of different workability. Collapse slump. In a collapse slump, the concrete slumps completely. A collapse slump generally means that the mixture is too moist or is a highly workable mixture, for which the slump test is not appropriate. This means that the water-cement ratio is very high, that is, the concrete mixture is very wet or is a highly workable mixture, for which a slump test is not appropriate. Shear slump. In a shear slump, the top of the concrete cuts and slides to the side. Or, if half of the cone slides downward on an inclined plane, the slump is considered a shear slump. The shear slump indicates that the result is incomplete, and the concrete needs to be tested again to obtain valid results. If a shear slump or collapse is achieved, a new sample must be collected, and the test is repeated. If the shear slump persists, as can happen with aggressive mixtures, this is an indication of a lack of cohesion of the mix. What is a zero slump concrete? When the concrete not falling down on the pan after removing the mold is called zero slump. It states that the concrete was too stiff and had less water-cement ratio. Applications of slump test. The slump test is used to ensure uniformity for different batches of similar concrete under field conditions and to verify the effects of plasticizers on their introduction. This test is very useful on the spot, as checking the variation from day to day or hourly in the materials being fed into the mixer. An increase in a slump may mean, for example, that the moisture content of the aggregate has increased unexpectedly. Another cause would be a change in the classification of the aggregate, such as a sand deficiency. A very high or very low slump gives an immediate warning and allows the mixer operator to resolve the situation. Thanks for watching. For now, please subscribe, like, share and do not forget to press bell icon.